Get ready to go on a journey deep below Earth's surface, through small, dark passageways and along narrow, slippery ledges. For many people, the mystery of caves is irresistible, and for thousands of years they've been luring people in. The evidence of early human presence in caves is overwhelming. Here in Mammoth Cave in Kentucky, prehistoric drawings confirm that early humans took refuge in caves, seeking shelter in some of the most spectacular natural structures ever formed. Unlike the outside world, caves such as Mammoth have almost no variation in humidity or temperature. As a result, even fragile materials such as wood are preserved for centuries. Native people fashioned this wooden ladder 2,500 years ago, and these cave drawings depict animals that haven't roamed North America for thousands of years. Passageways offer more evidence of early human explorations, such as the remnants of torches that were used to see in these pitch-black caves. Like our ancestors, people today continue to be drawn into caves. At the bottom of these deep, dark passageways lie mysteries that scientists are eager to explore. We now know that there is life even in the total darkness of some caves. Who knows what other surprises may await? Why are ancient artifacts so well preserved in a cave environment? As you watch this segment, think about how weathering, erosion, and deposition contribute to the formation of caves. Stretching for hundreds of kilometers below west-central Kentucky is Mammoth Cave. This is the longest and most extensive cave system in the world, with passages measuring more than 500 kilometers and still growing. Those who descend into these dark and winding passages enter a gateway to the past. But what created these marvels? Weathering and erosion did. Weathering is the chemical or physical processes that break down rocks on Earth's surface. Erosion occurs when water, ice, wind, or gravity carries the weathered rock away. Both weathering and erosion are still at work today in Mammoth Cave, continually lengthening and adding passages. Mammoth began as solid limestone. This area is part of what's called karst topography. Karst topography is an area where there is limestone near the surface. Over time, weathering and erosion result in many caves. Here's how it happens. Water seeping through the soil carries carbon dioxide. This carbon dioxide dissolves in the water, forming a mild solution of carbonic acid. As the carbonic acid solution flows through cracks in the limestone, it breaks down the rock and carries it away. This weathering and erosion results in cavities within the once solid rock. The smaller cavities become larger, funneling even more water from the surface into the ground. As a result, even larger chambers and passageways form. That's what happened here at Mammoth. The water flowed through the limestone and downstream to the Green River, carving out passages in the process and creating the massive chambers of this great cave system. But all these changes didn't happen overnight. The process has been going on for millions of years. Artifacts suggest that Native Americans first explored Mammoth Cave about 4,000 years ago. Today, there are no people living in Mammoth Cave, but there are more than 200 species of animals found here. Bats and crickets live in areas of the cave that during the day offer a kind of twilight world. Other creatures, such as colorless, eyeless crayfish, inhabit the dark. Like deep-sea dwellers, these species have gradually evolved adaptations to life in total darkness. As caves go, Mammoth Cave is visitor-friendly. Established as a national park in 1941, Mammoth Cave welcomes visitors year-round. But in general, exploring caves is not for the faint of heart. For the daring, the reward is the thrill of the unknown and the chance to go where possibly no one has gone before, and to see things you have never seen before. After all, no two caves are exactly alike. Erosion is an amazing sculptor, but when it comes to the magnificent formations found inside some caves, like the caverns of Sonora near San Antonio, Texas, erosion receives help from a process called deposition. Deposition takes place when erosion leaves behind sediment. In this case, calcium carbonate, also called calcite, dissolves in the water seeping through the cave walls. As this water hits the cave air, the water evaporates, leaving behind the calcite. As more water splashes to the ground, more calcite is left behind and hardens. The end result of this process is calcite deposits that are called speleothems. The shape of these deposits depends on where the water evaporates. For example, when a drop of water forms on the ceiling of a cave and evaporates, it leaves behind a small amount of calcite on the ceiling. As more and more drops of water form and evaporate in the same spot, the calcite deposit grows larger. Eventually, these deposits appear to be growing downward from the ceiling and are called stalactites. If the drop of water falls from the ceiling to the ground and then evaporates, the calcite deposit is left behind on the ground. More and more drops on the same spot build up deposits that appear to be growing from the ground up. These are called stalagmites. Calcite deposits, like caves, form very slowly over time. This 12-meter-high formation may have been more than 200,000 years in the making. Scientists go into caves to study geological features like these that can't be found on Earth's surface. By allowing us to see and understand rock layers deep within the ground, caves provide clues to Earth's history and structure. The powerful forces of weathering, erosion, and deposition contribute to the formation of caves and calcite deposits, whose beauty and mystery beckon the curious and the daring into these underground realms. In what kind of rock are caves like Mammoth Cave found?